So now we have a time programmed to have a general discussion about any aspects of our talks over the last 2 days. So if anyone has any comments or any points they'd like to make based on all of that, they're welcome to make them now. Never. or I don't know, or comments on if we should do this again, or that kind of thing.
Ben, maybe I have a comment. I have a comment or a question. I don't. I mean, if regarding all the talk we had since yesterday and discussion, I was wondering because what we saw is like in BIAM as mentioned before, we are working more on a small, I mean, for organism and at not the same scale. And I was wondering how we can use this model that you are using, like for smaller scale, or how we can interact with this model, how we can, what will be the idea for us to collaborate? How is it possible, for example, like Christine showed that we can use some model, but even so, I was wondering how much plans do you need, or what is the value you use and how you do it from the field, from the, I don't know if I, yeah.
Is your question for the big model like Orchidea, or?
No, I mean, I don't know exactly, because we heard about a lot of model, but we don't know exactly what will be, how we can use this model and how it will be interesting to combine our, I mean, the scale we are using, the different scale we are using.
I don't know who is in the room, but Fabienne, can you?
Nicolas Richard is talking.
If you refer to Orchidea, so it's sure that, I mean, it's dedicated to large scale modeling. So I mean, global or continental scale, but I mean, as it has been mentioned by Philippe yesterday, there is not specifically a scale, I mean, a specific scale related to the modeling. So it's more related to the hypothesis we put inside the model that are better matching global view, in which, I mean, we assume that we cannot put all the mechanisms or interaction that, I mean, are, and that you can account for at finer scale. But for instance, if we refer to stomata or exchange of photosynthesis, we have a scheme. It can be improved, as it has been shown, and we can account for new variable, new processes. And anyway, we can also be limited. We can limit the scale, but we can extract some component to also constrain those components on which we want to focus, for instance. So let's imagine we have experiments where we may know leaf nitrogen content, which is a variable in our modeling framework, might be constrained in a kind of simplified Orchidea in such a way that we are closer to the experimental condition that you can have. It's part of the answer. Certainly not all. I don't know, Nicolas.
Yes, I think that Greenscale is a good example of the things that we can do, because in this case, I think that from the side of the process, we can have from the experiment, etc. We can use what have been done to improve some parts. So this is really Greenscale a good example on the fact that using the fact that we take into account differently the Rubisco and the chlorophyll which is something that we don't take into account in the model, but can be very important for us. So I think it's a good example. As Philippe said yesterday, I think that what is interesting with Orchidea is that we can test some hypotheses and see the impact of this hypothesis at larger scale. So it means that it should be seen as a tool when we can, we have some hypotheses on some process, even if it's relatively small scale processes, but that we can take into account, we can test the impact of these processes. Of course, we simplify the things because we consider one type of plant everywhere or something like that. But what is interesting is that we can have find the order of magnitude of the impact of this process if we take this into account in large scale. And then after, of course, we can think to improve, to define it for different kind of PFT. But on the first order, it's allowed to test such hypothesis. So I think that if you have some, you find some process, specific process, it's something that we can test and see if it has an impact if we look it at large scale.
I think we have a gut feeling that we can learn from each other. So we just have to fake it until we make it. So we start project. We're not sure what we will find, but I'm sure we will find something worth discussing together, and this will lead to wonderful new knowledge, I'm sure, and new applications that maybe we didn't thought about at the beginning. Seeing the images of the stomatal conductance you have shown yesterday, I'm sure we can collaborate on stomatal conductance.
One thing I'd like to mention is that there's an initiative that was formed recently by plant molecular biologists and geneticists and physiologists called Plant Act. And so it's like there was we had a congress and people decided, these plant scientists decided they wanted to do more for climate change and for addressing climate change, both in a communication sense. I think Natalie is involved in this too, both in a communication sense and maybe also thinking about, for example, carbon capture approaches using plants, for example. So this is why this Souverain project interested me because of that. And so there are actually some meetings planned and things like that. And I think people at the LSCO who can use models and things like that, that could be quite interesting because that would prevent us plant biologists from making dangerous mutant plants that then go and completely mess everything up in the planet. But I think that's necessary. It's necessary to do modeling to be able to understand. We can't just go and change stuff without trying to work out what effect that will have on a big scale. Because we need big scales to be able to capture carbon. So if anyone's interested in participating maybe in some of these Plant Act meetings, then yeah, please mention to us and we can I can give you the links to the meetings. Okay.
Fully science related, but in terms of funding, so a lot of presentation mentioned the DRF impulsion, but I think this is, behind us. And so I don't know whether, I was wondering, even if I'm here, I should be aware maybe that there is no more specific funding in terms of CA that may promote
PTC, no?
Yeah.
PTC, PTC program.
Okay.
Program transfer for the for PTC, PUF. It's one is exploratory, one is for more collaborative work, but more based focus on some focus each year. more clear keywords. This is what I know. But what Fabian said about, yeah, let's just try. But I think it's good, but since we are physically far away, for some labs already like Thierry or Christian, they know they're already talking a bit about the same language, scientific language. It's easier. But for people who don't know at all, I think if it's no top-down initiative, it's harder to just say, yeah, let's try this without programming something concrete. I don't know how to say it. Because we have a limited PhD student, it's for 3 years, so it's sometimes take the risk to do something unknown without knowing it will be funded or not. No.
But I
How do
started
you see
working
this
with
concretely?
Anya because indeed, and
Yeah.
you know Anya Krieger,
Yeah, we
she's
also
working
met.
also at Molkel, but
Yeah.
she's here. I mean, she's a
Yeah,
few.
we also
miles
work
away,
with
so-
Anya.
And this year, we also submitted a PE,
Okay.
not knowing what to go about. And we have last year, we also had a first INR project together accepted. And formerly, we had a PhD student. So it was the unknown. I mean, in the end, yes, a
Yeah.
few papers, but it was just a first approach. So I learned a lot about the electronic transport and cytochrome and stuff. And she learned about global scale. So
Yeah.
we are just getting in touch. But yes, it takes years, decades. But I'm happy we finally have this project, maybe funded Green Scale. So for us, it's really a big hope, this Green Scale. And then we can go and visit you in the south if we are funded, and we
Yeah.
should have PhD between the two labs.
Yeah.
I hope there will be something between Gilles and Marion.
Yes, absolutely.
Marion, you can introduce to Gilles to colleagues who could answer his glycolide problem and the productivity in the ocean. So yeah.
Yes,
They can be transmitted to David and Philippe, and then they can see if they can get some money from the DRF, or I don't know. I don't know what is going to be done with the money that CEA is supposed to receive from the government, so maybe it's time. We have
mainly
to
nuclear, I
propose
think,
some
yeah.
project and see if.
I think the money from the government is mainly for nuclear topics. From what I heard from DRF Council just before Christmas.
Yeah.
So they said that DRF Impulsion will not be reconducted.
Yeah.
But maybe
Yeah, I mean,
the fact that Philippe Chomas came and the two people,
so we have to come back to them with some recommendations.
some projects.
What he told me actually is there will be a follow-up scheme, not like perhaps not identical to DRF Impulsion, but there will be kind of seed initiatives allowing for group de travail or workshops on specific topics. I think that would be good.
You had a DRF Impulsion where you start working with Omix people.
Yeah, yes.
DRF inclusion started already a few years ago, right? 2019 or it's already stopped 2020. The DRF inclusion.
C'est quelque chose qu'on pourrait considérer.
Oui, je pense qu'il faut voir que ça sort. Our speed dating was successful, so we start to talk about ourselves. No, I mean saying this new scheme, we have to wait when it's announced, and then probably it's an opportunity to identify. Perhaps you have more information, Nicolas.
No, I wanted to mention because it has been mentioned also yesterday by about this initiative that has been launched at the DRF level, the network, so network, réseau métier, réseau
Physics, biology interface.
as well, this physics biology, in which part of the collaboration we have presented between William and Elsie will match. I mean, it's a big, actually what they put in that interface
it's huge.
is quite broad, and I mean, there are at a minimum 6 communities, I mean, from biomaterial to what did for some
modeling
with the genomics, and so, I mean,
It's difficult.
I don't know what you can find as common, but typically they will launch that initiative. It's more like a networking. So so far we do not plan some sort of funding of grant or whatever. But who knows? I mean, maybe if there are solicitation for more.
So my
budget is 50 euros
50 per year, yes. So it's for now, the kickoff will be in 2 months, roughly. And I think it'll be an opportunity to define what these key regions are at the interface.
Yeah.
And so I tried to push a bit the photosynthesis question for, I know a lot of my colleagues, because we use tools that to study photosynthesis that are more physical, but it can also be the other way, if modeling wants to incorporate biological systems. So it's really early and it's very difficult to define this interface. But I think if there is a presence to define something, because eventually the importance will be on young recruits. That's one of the ideas Philip was telling us, that we want to find a way to attract more people into the DRF to do this kind of fundamental work. So hopefully it could grow into, new grants for PhD students. So.
So anyway, so there will be this kickoff meeting.
Yeah.
Feel free to join. The more we will be.
Yeah. Exactly. Yeah, I think so, because it'll be, right now we don't know how many people will be there. So if a lot of people show up with this interest, then it will go that way. Likely there'll be some.
They should start circulating
the announcements should be this week, I think.
Danny, you are talking about this Resume métier or?
Yeah, it's not métier chimie. It's actually another, because Catherine is on the métier chimie. This one is another one. It's like not the métier, but it's the réseau thématique de recherche. So it's more on and that's what's so difficult, that it's biology, physics. There's so many topics. So, but it'll be a chance to maybe define the key ones that are.
Okay, are there any more comments? Would it be useful to have some kind of like written thing, like a resume or something like that? For some of the points, we could maybe, I don't know, maybe we could.
Yeah, we can write 1 page.
Yeah, something short.
Watch all the videos again.
Yeah. Maybe online, if they want to add something, maybe Christine.
Does anyone online want to add anything? No. So we have a final word programmed on the program, but I'm not sure what we should say, except thank you very much to everyone who gave talks. And it's not always easy, especially when we don't know what the links could be. It's not very easy to give the talk. So thank you very much for doing that. And thank you. It was great to work with Christine, Fabienne, and Nada for preparing this. So thank
Ben and Virginie.
Thank you. Yeah.
Thank you very much to everyone, in fact, speakers, attendees. And so next time we'll be at Bienne. Yes, in 1 year or 2 years, I don't know. We'll see.
Next year or in 2 years, I don't know.
Yeah, maybe not summer.
So,
But,
yeah.
In institute here, they presented, you have 3 research axes or 3 elements.
Yeah.
So in this community, this joint committee, this gamma, that's represented from 3 different axes, or it's more, we have more find common points with 1 bigger axis.
No, you want 3 axes. The 3 axes were here.
Okay, so we can all find something common.
Well mixed. And like some transverse, photosynthesis, something
And thank you also to the LSE for their welcome here to us who came up. That was It was great, thank you.
So we can share the meal, right in front of this room. So we are welcome to share the meal with us.
And maybe now you have time to visit our installation and equipments. I'm sure Arnaud would be very pleased to show you.
Yes, we're going to try to have a visit. Well, thank you.
Thank you.
Our Micadas is beautiful.
So bye. Leftovers from yesterday evening. Okay, that's nice.
Everybody.
Thank you, thank you.
I go to.
Ciao.
Bye.
Bye.
Bye.